Right, so tomorrow the lab session there, I'll be there and Tia will be there. Optional attendance, but it's more like a Q&A for lab session tomorrow. But next Friday will be your programming test number 1. All right? And the guide for your programming test 1 has just been released earlier this morning. Please check the coverage and also policy, requirement, etc. Please make sure you read it through. And there will be a practice test. We're still finalizing it. Latest time I'll release it will be Monday, early Monday. But if I can release that earlier, I'll definitely release earlier. But I'm still finalizing some details over there. I want to make sure it's appropriate before I can release it. And there will be a review session most likely next Wednesday. It will be in person. I'll touch base with you guys pretty soon in E-class. And we're still grading your programming test 0. As soon as it's ready, I'll definitely release it. And we'll talk about it later. And your priority now, of course, you should really go through the lab 1 solution if necessary, to really get all the doubts clarified, and also your lab number 2. All right, it's been released just from Monday. Lab number 2 is also very important, not covered in programming test 1, but it will be covered in programming test 2, and later on in the written test. So please, just keep up with the study. And also the slides that we have covered so far. And today we'll just move on with JUnit testing and some interesting examples. We're going to do lots of examples today about tracing, execution flow, exception, etc. Okay. Any questions about the course? Alrighty, let's do a quick recap from last time. So last time we just did more examples on the exceptions. That's the last part of the lecture. And we did this kind of extended version about the circle calculator. And you can definitely refer to the recording for the detailed walkthrough, but you really want to pay attention to this particular Boolean variable. And also, whether or not the exception is actually thrown from this line here, you may either go for normal execution flow, or you might go for the abnormal execution flow. It's really always the binary possibilities you have to be aware. And we're going to emphasize that for many examples that we can talk about today, right? It's so important, right? And then we talk about this banquet example there, pretty much the same. We just got a call stack, a call chain of 1, 2, 3, 3 methods. And the line to highlight would be if you got an expression like this, like a dot notation, the context object here is not just an array variable, but indexing into the array. So you got to know how to figure out the type of the context objects. In this case, it would be account. So you will know that the callee in this case will be account dot withdraw. So you know which method to step into, right? So that's really the more highlights for this particular example. And then we spoke about if you got multiple catch blocks in your code, it's simply because you got multiple lines that might throw different kinds of examples. And as we said, for now we assume that you will only got the customized exceptions, in which case it doesn't really matter the order in which you kind of organize the catch blocks. But later on, once we talk about exception, if time permits, I will talk about when order of the catch block may matter, where you have to consider inheritance. But before that, you don't have to worry. Okay? And that was the final example for the exceptions lecture. It's a very interesting application, again, about the normal versus abnormal execution flow. You just have to know about this particular method called parseInt. It is a static method from the integer class. Look into it. They also got other methods as well. Parse double, parse character, etc. Right? Take a look. I think it's going to be useful for your other endeavors, maybe outside the course. And we also spoke about this example here. This line here may or may not throw the number format exception. So if your flow goes normal, it will go here. If it goes abnormal, it will go to the catch block. Right? Again, binary possibilities. Which one is going to occur at the runtime really depends on the input. So that's why you got to be aware which flow is going to go at the actual runtime. All right, any example? Any questions about the exceptions lecture? All right, so the exceptions lecture are basically done. I think you guys should really catch up with the slides and go over all the examples that we spoke about in class and try to digest them, and then do your lab 2. I think that'll be the best way to really finish the learning about exceptions. Okay. All right, so this part here, just about console messages. We will do some exercise today similar to that, but I think that part there, please do go over the slides. I think there are some important points over there, but you can definitely study that yourself. But reach out to me if you got any questions about using console messages as opposed to exceptions to handle errors. Definitely the winner should be exceptions. Okay. All right, and then we move on to the new lecture about test-driven developments, or TDD, using JUnits. And it's quite a small lecture, but I think that there are many examples that are really worth our attention. It's a very straightforward application, or very natural application of using exceptions. That's something I'll talk about today, right? I'll clarify some general ideas before we dive into examples. So this part here is just about the review of the catch was specified, right? So if you specify, you just say throws as part of the header for the method. On the other hand, if you want to catch the method from the callee, it will just say try and catch block, right? So these are the two possibilities when you are subject to the catch or specify requirements. And this is the running example we're going to use for the rest of today and possibly a part of maybe Tuesday, but mostly today. We have a bounded counter. Counter here, we got define maximum, minimum, so between 0 and 3. So only 4 possible values for the counter. If you want to go above or beyond, if you want to go above or below, you will definitely trigger some exception. That's something we're going to see today. And in the beginning, initially, counter will just be initialized to be 0, the minimum value. So there are 2 possible scenarios where things might go wrong. Either when your counter value right now is too large for you to do increment, in which case you should really trigger value too large exception. So you guys can really take a look at this if then else. It's quite straightforward to really go through. Symmetrically, things might go wrong if you try to decrement when your counter value is already a minimum. In that case, it should not really decrement to -1. You should not. So you might throw value too small exception, right? So these are the 2 possible exceptions we're going to play with. And then we talk about this diagram here. So deriving test cases is not really within the scope of this course over here. For those of you who might be interested, there is sounds like a software engineering testing course in the 4th year. If you're kind of interested in deriving test cases, that might be the course to take. But for this course, we will always give you the JUnit test cases. But for this simple example here, I kind of show you, for simple variables, you can derive test cases like this, right, using a state diagram. You basically enumerate all the possible values for your variables and see how to go from one to another using different method call. So there are 2 categories of test cases we're going to derive today. Category number 1, when you don't expect any exception to really occur. For example, if the current value is 0, you want to increment to 1. You only expect the value of the attributes to change from 0 to 1. Similarly, if you go from 2 to 3, there should be no exception expected. How many cases should we really test? You want to test from here to here, here to here, and here to here. Also here down to here down to here, and here down to here. We got 6 different test cases for you to really test, right? So in the slides, I did suggest some exercises for you guys to try to write some JUnit test cases yourself. But just remember, the first category of test cases will be when you don't expect any exception to occur. If any exception actually occur, that should be unexpected, and your test should fail. That's number 1. Number 2 will be completely the flip side. Let's say if the current value is already the minimum, and you're still calling the decrement method. Also, if the current value is already the maximum, and you're still calling the increments. In these 2 cases, you're basically triggering some exceptions over here, because you should not really allow the updates to really happen. So in these 2 scenarios is category number 2, right? So category number 2, okay, let me just say that, just saying. So that should be category number 2, where you do expect some exception to occur. However, in this case, if the exception did not occur, in that case it's unexpected and your test should really fail. So to really decide whether a test should really pass or fail, you really want to be clear about what the expectation is. That's something we'll also need to review today. All right? All right, any questions so far? That's only a recap from Tuesday. Okay? Let's now go over, just move on. The slides I'm going to talk about on my iPad will be mainly slide number 9, just about different components of a test. But I want to present in a slightly different angle. But you can definitely read the slide to get more knowledge. But let me just go over here, right? I want you to be very clear about exactly what is what, okay? Let's say this. Let's say in your given JUnit test class, you have a test right here. How do I know it's a test? Because you know it's a method, returning void, and we have a test tag. That's what we mentioned in lab number 0. Whenever you got a test tag, that means that method there will be treated as a test case by the JUnit framework. Let's now try to somehow break down this particular test into different parts and really understand what's going on here. You will need a kind of clarification mentally. Okay? So let's start with the method itself. So this test over here is what we call a test method. So this is JUnit, of course, it's JUnit, but if you're using another programming language, maybe C#, it wouldn't be JUnit, but just test method. Test method. All right? And the test method happens to be the caller. Meaning that it's actually going to call the method you want to test. All right? Okay, let's move on here. And there you can see we got some assertion over here. Every time you see assertion, you know that it comes from the JUnit framework. And the 23 over here is the expected value. The convention is when you are trying to assert equals, the first value that comes will be the expected value. This will be something you expect to happen. Expected value. When you've got something that's expected, you should really compare that against what actually happens from your software. If they match, pass. If they don't match, fail. All right? So let's take a look. So first of all, you can see that over here, get value. One moment. The get value here. So this is so-called the method under test. Method under test, or it's basically a callee. So the caller, which is a test method from JUnit, is calling this method here under test as a callee. Okay, and then the actual call, the context object and the test method under test is going to return some value, which will be the actual value you want to compare against. So this part over here, o.getValue is a method call. That one there is really the actual value. So if the expected value matches the actual value, great, pass. Otherwise, fail. Okay, let's now put this into some visual. Okay, just to be very clear. So what we have is we got our JUnit test framework over here. Okay, put it a bit up. Okay, we got here. So we got our JUnit test method. In this case, it's simply the method called test. And then that one there is going to take several inputs. Input number 1 is going to be the expected value. Okay, you can think about it's going to be the expected value. Expected value, and also in this case, it is simply the 23, right? That's the expected value. That's only one of them. And what about other parts for the inputs into the JUnit test framework? It will be the actual method you're trying to test, the method under test. So let me draw another box over here. So another box will be right here. Okay? So this will be the method under test. Under test. And of course, in this case, it will be the get value method. Get value. All right. In general, the method itself may take some arguments, right? But in this case, it's simply empty. But imagine that if I pass 23 over here, then 23 will be passed right here. But in this case, no. Okay? Just in general, you may take some arguments for your method call. So I'll just say in general, you may have to pass on input. You say arguments. And then the method may return some return value. That will be the actual output, right? That will be the return value. All right, so the return value over here is going to be treated as another input to the test method. So think about the return value over here is actually right here. Right? That's just another input. And also, the argument itself will also be that as well. Okay. Over here, and also the method under test as well, right? Basically everything over here. All right, let me just recap very quickly. So the JUnit test method here, right here, is going to take several things. Number one is going to be the expected value. And also everything else will be sufficient for you to execute this particular method and get some value, that's return. To really get this one done, you need to know what method it is. So that's one of the input. And also what's its input, what's its arguments, and execute it, and what's its output from there, right? So all these together. What can be the result from the JUnit test method? Either pass or fail. All right, so from here, it's either pass or fail. You may actually pass, or you may actually fail. The reason I really wanted to visualize this is because you can see there are two methods over here. You got one method here, you got one method here, but you should really know the roles they're playing. Okay? When things get a little bit more complicated, you want to have that kind of mental model to know what things are. Okay? Questions? All right, if no, before we dive into lots of examples, let me talk about one more diagram, which will be the test-driven developments. I think that's also important. Okay, that one there. So components of test, take a look. Pretty much what I just said. And also we're using JUnits. And that's the diagram I want to go over with you on slide number 11 very quickly. That would be kind of the process you're doing anyway for every lab and every programming test. But it's good to just make it more written down so that you do it once. Okay, let's go over the process. It's basically an iterative process, which means possibly it may never end, depending on how long your project is going to last. If your project is going to last for 5 years, then this process should really go for 5 years. If your projects are still ongoing, so this one should still be ongoing, and etc. Okay? Let's start with the first part, which will be the model part. So you can see this part here is your model package. So these are all the classes that's going to implement the business logic, right? Anything that's kind of intelligent or something done by you as a developer should really go there, okay? In our running example, it will just be the counter, okay? So let's call that just the model, okay? That's really the part where we want to somehow test to see whether it's correct or incorrect. And let's say you have done some initial developments, and the next step is you somehow want to derive test cases to really verify its correctness. So the second step would be right here about derive. And as I said, for this derivation process for the test cases, you're definitely encouraged to try, but it's not required for this particular course. In this course, you're only required to read the test cases you're given during the programming test and program accordingly. But you wouldn't be really tested on deriving test cases. Usually it would just be given. Okay? So for this part here, for example, I believe it's EECS2030. I'll check for you. Okay, maybe I'm wrong, but I think it's one of the fourth year courses that's going to talk you through only about test strategies. Okay, so you're just going to figure out, exactly how many test cases you're going to test. You want to be as complete as possible. As complete as possible with respect to the problem description. So based on the problem description you're given, what kind of simple scenario should you cover, right? You want to cover as many as possible. That's really the essence about testing. So once you have got all your test cases, you're going to code them up in JUnit test methods, right? As many as you can, all right? So that will be all the JUnit test cases, okay? And once we have got there, we're just going to run. Just say run as JUnit test class. And the JUnit test framework is going to give you either a red bar or a green bar, right? What's really the difference over here, okay? So when you get a green bar, let's say here, That means your software, well, first of all, green bar simply means all the test cases you have developed so far pass. That means all tests pass. That somehow imply your software is, I quote, correct. Your software is, quote, correct. In the relative sense, with respect to the test cases you have so far. If your test cases are rather complete, then this correct can be with higher confidence. But if your test case is really testing the same thing, but you're just repeating that 1,000 times, it doesn't make sense. It doesn't really help. Okay? Okay, it's correct with respect to the tests run. So the practice is you want to, the more aspects being tested, the better. The more aspects being tested, the better. The better. For example, let's say your method somehow is going to manipulate an array. You don't really want to just test maybe something about array being of length 5. You may want to test what if the array is empty and what if the array is very large, etc. You want to think about different input scenarios depending on the problem description. All right, so this part here is really critical. The more aspects you can test, the better. So the actual number of test cases usually don't say much because if you're testing the same thing over and over again, it's not going to add any value. All right, so, but it's good to get green bar anyway. And let's say if you get a red bar, what does that mean? That means at least one test actually failed. At least one. So at least one test failed due to a mismatch of, remember talking about password fail, it's really about expected versus actual value of expected and actual value. At least one. And of course, if you really get a red bar over here, what you should normally do is you should really try to go back to the model classes over here and try to find the bugs and fix them. What will be the best way, the most effective way to really find a bug? Breakpoint and debugger, of course, right? That's why we kind of taught you right in the beginning, okay? So what you're going to remember is if you want to find a bug over here, you want to use the breakpoint and debugger. That's really your best friends. Breakpoints and debugger. And the reason that I said this process here will be ongoing, even if you have got green bar, let's say over here, that might be only for now. It's very possible that you might get some request about either to extend or maybe to maintain somehow your model classes. In which case, if you make some changes to the model classes, you should always rerun all the test cases and make sure you still get a green bar. Very likely, any new change you introduce to your model classes might just get a red bar, in which case you gotta fix them. All right, so the extend and maintain here is really the nature of software project. You cannot expect only one cycle of developments, not really. All right, so this part here is actually very important, right? Ongoing. So this one actually tells you that the TDD is iterative. All right, so one more advice I would give. Also, your development should be incremental. I'll write it down and I'll explain what I really meant. So you should really aim for incremental developments. So let's first of all tell you what is not incremental. Let's say you're given certain task, you're only trying to code up everything to your satisfaction, and then you start writing test cases and try to see if you get a green or red. Maybe only after writing hundreds of lines of code will you actually write a test case to test them. That'll be too late. That's not the way to go. Incremental development simply tells you that as soon as you have programmed certain logical units, no matter how small it is, you should really start testing to just make sure that small units, a single method, even a getter or setter, actually work. So rerun all the tests after each small logical units is implemented. Even for the particular method, maybe you believe that there are so many scenarios you have, so many if conditions you have to handle in a single method. Maybe as soon as you are done with the one single branch of condition, test it right away to make sure that condition is fine, right? So that's really the way we kind of organize the test cases in your lab just to get you used to it, right? But incremental developments is really the way to go, right? Especially you want to do something that will really scale over in the long run. Conceptual, easy to understand, but hard to really practice, right? So that's why we got so many labs for you, we got so many tests for you, so you really want to practice them, all right? Any questions? Yes?
The concept of incremental development, is it also applied in our labs and practice?
Yeah, for sure. Incremental development is exactly what you do for the labs. For example, you don't really want to maybe try to program all the classes that's required by the labs before you even run the JUnit test button to see if that's green or red. Yeah, you really want to go for one test after another, or sometimes even one assertion after another, right? And also make sure you always keep saving your file, because in Eclipse, every time you save your file, it's going to compile everything together. You don't want to say, I don't even save my file after 1 hour of coding. As soon as I save, suddenly I see 100 compilation errors. That's not the way to go, right? That might happen. Hopefully not to you, but it might happen to your fellow students, right? All right. All right, let me now go on. All right, so that's a test-driven development, guys. I really encourage you to really try test-driven development. It's not just particular to this course. It's just very sound practice for software developments in general. All right, so now from, let me just be precise, from slide number 12 to, give me just one moment. Sorry, my notes are not exactly in order. Bear with me. Okay, from slide number 12 to slide number 21, it's just about JUnit test knowledge. I would say that one day you have already learned it from lab 0. So most likely you don't really need to worry too much about them because you already know them. But you can skim through them. It's just like a reference point about how you can create JUnit test cases, how you can run it, more like a tutorial slides. So from 12 all the way to 21, right? So that one I'm not gonna repeat in the lecture. Only 2 slides specifically I can talk about them very briefly before we talk about lots of examples. All right, all the way to 21. Right? It's just more like a reference tutorial slides about how you can create and also understand and also run the JUnit test. Okay? But there's one page I want to speak about very quickly. Okay? Let's start with this. This part here is actually from slide number 16. Okay? So just in case you need some reference. So this one here is actually from slide number 16. And this one here is actually from slide 19. Okay, I just want to talk about these 2 specifically, just to make some point. Slide number 16 here, part of it, this part here, just define what does it mean when you run a JUnit test case when it fails. Well, of course, conceptually, it fails if you have the expected value not matching the actual value. That's one way to see it. Another way to see it, which is about more like a programming, more like a runtime behavior. Think it this way. It will fail if either you got some assertion failure. Assertion failure can be many sources. Can be assert equals, assert null, assert true, assert false, etc. Right? We talk about them also in the lab. If you got any assertion failure, and I'm going to talk about this one specifically in this page. That one might seem pretty peculiar. Why would you fail deliberately? Why? Right? I'll talk about it. So if you got any assertion failure in your test, you're going to fail the test. Or if there's any unexpected exception. I would say for this course, you can assume unexpected exception, at least for now, will be null pointer exception or array index outer bound exception. If you got any of these exceptions here, you might also fail the test. Okay, so these are the two possibilities. If you don't have either one of these, then your test should really pass. All right, so that's a clear definition. And then I want to talk about just the fail, how it works. Okay, very quickly. Whenever you are trying to maybe create a new JUnit test class, this will be some method that will by default will be given to you. Right? It simply gives you a test over here, and then it's going to say fail, not yet implemented. That's exactly what you will get. You may have seen that already in lab number 0. And if you run this as a JUnit test class, you're going to get a red bar. All right? So fail here is actually listed as one of the assertion failure that might be possible. Fail simply means I want to fail this test right here without continuing. Okay? So now, based on the definition over here about passing or failing a test, we know that fail is going to fail the test right away. What would be the shortest fixes to really get rid of this red bar and turn it into green bar? What would be the shortest fixes? Shortest. I didn't say simplest, I say shortest.
Can you put like an exclamation mark in front?
Explanation mark? You mean, oh, I know what you mean. You're saying something like that?
Yeah.
That one there, I'm afraid you will get compilation error, right? Because fail itself is actually not a Boolean expression. Good try. I know what you're trying to say. Not failing, right? No. I'll take one more response and then I'll tell you the answer. Yeah? Remove line number 7. That will be almost, that's basically correct, right? What I was about to suggest was you simply just put 2 characters over here to comment it out. Because if you do that one there, when you want to re-execute the test, the fail will just have no effect because it's been commented out. Basically the same as removing it. Okay, pretty good. So this question here is actually quite important because what's the easiest way to really have a passing test? You just have nothing there. Remember what I said earlier about test-driven developments over here? Let's say I comment this out and I duplicate this test case for 1,000 times. And then rerun the JUnit test. I'm going to get a green bar and then I got 1,000 test cases passing. Does that give me any confidence about the correctness? Not quite, right? So that's why the quality is always more important than quantity about test-driven developments, all right? All right, let's make a very quick remark over here. Leaving the body of the test method empty will pass the test trivially. And of course, if you leave it in, only fail, it's going to fail that trivially. But this is something very useful, as we'll see in all the examples. Okay. All right, any questions about the definition of passing or failing and also how the fail is supposed to work? All right, we're going to see the fail here in a very critical way. Okay, we're going to see that. Okay, and just show you a little bit more. So there are some simple examples about JUnit test assertions. So this one here is actually from slide number 23. Okay, I'll just give you the reference there. And for these, I would suggest you guys give it a try just to see what the output should be, whether the test should be passing or failing, right? You can do that simple exercise, right? I'll leave them to you. Given that you have already done lab 0 and lab 1, these should be quite easy, so we don't need to waste time in the class. And if you want to see the solution, it's on the slides. That's from slide number 23, and this one is actually from slide number 24. Okay, and there's just one thing I want to emphasize very quickly. Right, you can see we got assert equals over here, and since now we are comparing some expected value that's actually double, like a fractional number, right? We said that for that one you have to give some tolerance right here called epsilon. And we did speak about this in the review lecture. So I would suggest you guys to review that part of the lecture about how the epsilon is supposed to be interpreted, right? For that one, I'll refer you to that. All right, so slide number 23 and 24, right? That one you can definitely study on your own. Let's now do the more interesting examples for the rest of the class. Okay? And let me just make sure I'm more aligned to my notes. There we go. Okay. Okay, let me see if there's anything else I want to say over here. And slide number 22, it's just about other assertions, but we have covered almost all of them. You can definitely look into array equals. That's kind of interesting too, right? It's also supported by JUnit tests. But for all the others, we have seen them in the labs already. And these are the two examples I just mentioned. So please take a look, and you can find the solution on the slides. And testing strategy. So this table here contains 8 test cases. 6 normal, 2 abnormal. They really correspond to the state diagram I kind of recap in the beginning of today's lecture, right? You can review them. And I'm going to talk about some of them, about how to set up the test case in JUnits. We'll talk about that in detail, so in just one moment. And for any other test cases we don't really cover in the lecture, they will be done in a very similar way. I also encourage you guys to really give a try, right? To really code them up. Okay, good. And let's now try to look at different examples. Okay, so what I'm going to talk about now from iPad will be starting from slide number 27. Okay, we've got many examples to go over. All right, the first one. So before that, let's now have a mental map over here. Whenever you have a test, you have some expectation. The expectation could be certain exception is expected to occur. Certain exception occur. And sometimes the expectation could be the other side. Expectation could be certain exception did not occur. Does not occur. So we got one expectation, another expectation. Depending on the expectation, you're going to define passing or failing of your test case differently or accordingly. Okay, let's now have some conceptual sketch, and then we'll see exactly those in the actual code. Okay, if our expectation goes like this, we do expect some exception to occur. Now, if that exception really occurs, that kind of exception really occur versus that kind of exception does not occur, right? There are only two possibilities, right, about the flow. Either occurs or not occur. Does not occur, right? Okay, let me just save a little bit writing. Let me just copy this. Because I got the same binary choice for the other expectation. Okay, let me just put it there first. Okay, right here. Okay, so in expectation number 1, since I do expect some exception to occur, if that exception really occur, that matches my expectation, in that case, my test should pass. This one kind of tells you that within your test execution, even if some exception really occur, it doesn't necessarily mean you should really fail the test. It depends on what kind of exception that's being occurred. If that kind of exception occurring is what you expect, your test should really still pass. That's how we should set up the test accordingly. On the other hand, if that kind of exception did not occur, in that case, we should really fail the test. Okay? That's for expectation number 1. And for expectation number 2. So here we say that the certain exception does not occur. We don't expect it to happen. However, that happened. Oh, sorry, let me just say this. And we don't expect that to happen, and it really does not happen. So it really matches our expectation. So in this case, it should pass. On the other hand, if it really happened, which is unexpected, then we should really fail. What does that tell us? One more time. In the case where certain kind of exception really occur, whether the test should really pass or fail depends on what your expectation is, right? So that's really the essence of how the example that we're going to go over. So you have to make sure this conceptual kind of correspondence really makes sense to you, all right? Any questions just about this kind of conceptual sketch? Okay. All right. Having this in mind, let's now go over examples. See some actual coding. All right. The first one, okay. Let's say right now we do not expect any exception to occur. Let's say that's our expectation. Okay. So this exception not expected. Right? That's our expectation. And the particular scenario that we want to really consider will be this. Let's say we have some counter object C, and we try to call increment on that. Okay? And let's say currently the value for the counter is simply 0. Do we expect any kind of exception to really occur? Not really. You will just increment from 0 to 1. All right? Specifically, we should not really expect a value too large exception to really occur. If you look at the increment method there, it specifies that it might throw value too large exception, but now we do not expect it to happen. All right? It is very important for you to know that for this particular example here, we're considering that this one here not expected to happen. And this is the test that will set up this particular expectation. I want you guys to really just take a look from line number 1 to line number 13 just for 1 minute and see if you can somehow see the logic there. Thinking this way. This is our call to the method under test, which may or may not throw the exception, specifically value too large exception. Think about the binary possibility. What if the value too large exception does occur? Versus if the value too large exception does not occur. How are the execution flows going to impact whether or not the test should really pass or fail? Okay, take 1 minute to think about it and I'll go over with you. So for the very first one, I'm going to go very slowly because the first one here, usually you might have some confusion, which we should really clarify. So this is the method under test, which we know may or may not. May throw the value too large exception as part of its header, right? It specifies it. All right. All right, so now let's think about the logic here, right? If we are able to go from this line to this line over here, does that mean the exception, value too large exception, occur or not occur? Not occur, which is expected. In which case, we don't really fail the test right away. Instead, we further assert if the value has been incremented from 0 to 1. Okay, that's the normal path. Okay. So from here to here, this one tells us the value too large exception did not occur, which is expected. And after that, we further assert, further check if the value is incremented to 1, right? Because you can see initially we assume that the value for the counter is going to be 0, whether it's incremented from 0 to 1 after the increment. That's the normal path. And then after this assert equals, if the value really has been incremented from 0 to 1, and then we completely bypass the catch, and we go all the way to the end of the test. No assertion failure, no unexpected exception. So pass. All right. Scenario number 1. What about scenario number 2? I'm still calling the same method here, right here, increment, right? Which we know may throw that exception. Now, the second possibility would be, rather than going from here to here, let's say the value too large exception really occur unexpectedly. In which case, I should really go to the catch block, right? As we learned from the previous lecture. And then, if we get to here, it's totally unexpected. The test should fail. That's why you see fail right here. This is the critical use about failing. To say, if I'm able to reach this point at the runtime, something unexpected happened. I should really fail the test right away without going any further. Okay? So this one really tells us if we are able to go from here directly to, to go from here directly to the catch. That tells me that the value too large exception occurred, but unexpectedly. The value too large exception occurred unexpectedly. In which case, fail the test unconditionally. Which is why you see the fail. It is very important for you to understand this scenario here because depending on what your expectation is, you may have to put a fail assertion in different places. In this case, we put it in the catch block because we don't expect that kind of exception to occur. All right, but we'll get to the other scenario. So far we only talked about the design of the test. Let's now try to trace the code to make sure it really is going to work. Okay. Let's test some input here. Let's say, whenever you're doing a test, let's say right here, one thing to note is the test over here, the method under test may or may not be implemented correctly. If the increment is implemented correctly, the test should pass. If the method under test is implemented incorrectly, the test should fail. That's really the requirement for the test, right? Otherwise, what's the use of the test? So let's now say the increment has been incremented correctly. Correctly simply means, let's say this is actually correct, in the sense that no unexpected value too large exception thrown, and also the value of the counter is actually incremented properly. Right? You can see those two requirements pretty obvious, right? You can see that here in the increment method, we say that we only try to throw the value too large exception when the current value is already the maximum, right? That one handles this one here, so no unexpected exception. And also, if we are actually not reach the maximum value just yet, we can safely increment the value, right? So that's the second part right here, right? So this is a correct implementation. Let's just try to trace this one here, right? Let's try that. So I'm going to start with this one here. We're going to create a counter, and just remember, after the creation, C dot value is actually equal to 0, the minimum. So that's why when you try to assert equals right away, you want to make sure C dot get value, which is the actual value, is the same as the minimum, which is 0. Indeed. Right? So these two match. So that should be a pass. Just for the assertion. So that's number 2. And number 3, we're going to reach the try block. And then number 4 will be, we try to call this method here, C dot increments, which you may or may not throw that exception. Right? So let's now step into. Number 5 will be right here, right, over here. At this point, the value for the counter is still 0, right? So C dot value equals 0. And what's the maximum value? 3, right? 0 equals 3, false. So we bypass. We don't really throw that exception unexpectedly. So we're going to go to the else part over here, and then we're going to increment the value, which would be, so it's number 6, we go to the else part, and this part here, we're actually going to increment from 0 to 1. Okay, that's number 6. And then number 7, where should number 7 be? Tell me a line. 7? Agree? Yeah, because no exception has been thrown unexpectedly, so we should go straight to here. All right? Good. All right? That means we go 7, 7 will be here. At the same time, we bypass the entire catch block, right? Gone. And this one here makes sense. We just want to make sure C.get value, because it has been incremented from 0 to 1, so now it should match the 1 over here. So that one, that assertion there also pass. All right, so after 7 here, we should really think about, we should really go to line number 13, which would be 8. That's more about the end of the test method here. So once we go there, no unexpected exception has occurred, so the test should really pass. Okay? So once we get to here, the test pass. No unexpected exception occur. All right, any question about this? Good. Let's do one more, and then we'll take a short break. Just do one more. How about this? Let's take a short break right away, because that one there will take a little bit more explanation. Okay, why don't I pause the recording? All right, so before the break, we talk about this particular test where we don't expect the value too large exception to occur. But let's now try to say the test remains the same. Your test value should not be just to show you that it passed. When it fails, it can also show good value. Let me show you. Especially when your implementation is wrong. Okay? Now let's take a look at this. I'm going to modify the implementation so that it's actually wrong. Okay? In general, you're basically saying you're testing somebody else's method. You're not too sure whether it's correct or incorrect. Your test will only be valuable if you can pass on the correct implementation, but it can fail on the incorrect implementation. That's something I'm going to show to you now. Okay? This is just the correct version of the increment. Let's say we are going to change something here. Okay? This guy here, I'm going to say it will only throw that exception if the value right now is less than the counted.maximum value. That's obviously wrong. All right? So guys, you see what I'm doing here? I'm modifying the implementation in front of you so that it's incorrect. And now I'm running the same test on this incorrect implementation. If the test is good enough, you should really complain about this incorrect implementation by failing. All right? Let's now trace. All right. Let's now take a look. So we're going to start with this. Number 1, we're going to create the counter, and don't forget, C the value initially would just be 0. And then if you check that, minimum value is 0, and C.get value is also 0. So this one here, no problem in the beginning. And then we go to the try block, number 3. And number 4, we're going to call this method here, right? We're calling the same method, but it has been somehow modified internally, so it's actually wrong. It's incorrect. Okay? So we're going to step into it. So if we step into it, we're going to get number 5 right here. All right, so now, C the value right now is actually 0, right? Still the minimum. And counter the max, as we know, is actually 3. 0 less than 3, true. Meaning that number 6 is going to throw that particular exception, whereas we're going to bypass the else branch completely. So this part here tells us we're going to throw that exception incorrectly or unexpectedly. So value too large exception is thrown unexpectedly by this incorrect implementation. All right, so that exception is going to be thrown. So now when we go back here, now where should 5 be? Tell me a line number. 9? Okay, very good. Thank you. Exactly. We got to catch it, right? So we bypass the rest of the try block, and then we're going to go directly to 9 because that exception has been thrown even though unexpectedly. So that would be number 7. So that would be number 7. Okay, so now here I'm going to make a comments for you. Over here, you can say the value too large exception thrown unexpectedly. And that's why you're going to fail right away. So this line here tells us that we should fail, something unexpected happened. We should fail right away without going any further. Fail the test right away, immediately. Immediately means that I'm going to just say something here. I'm just going to put a cross over here. That means if you got any lines of code that's after this particular test, you're just going to bypass that because you're going to fail right away. Okay? You can think about the rest of the test bypassed. Okay? Because the failure already occurred. All right, any question about this incorrect implementation? Let me recap again. A test is only useful if it can pass on the correct implementation and fail on the incorrect implementation. If you pass all the time or fail all the time, it's useless. Okay. So these two examples that we did after the break and before the break kind of shows us how your test can be set up where exception is not expected. Let's now change our expectation. Let's say we do expect the exception to occur, let's say, okay? And the scenario that I want to talk about, let me remind myself, is this, okay? Just before I show it to you, okay? Let's imagine this. I initialize the counter, so its value is now 0. But I try to decrement the counter. It should not be allowed. So now in this case, if I call the decrement when the counter value is actually 0, I should expect value too small exception to occur. Right? And what I'm going to show you is a different test design. And I want you to pay attention. I'm going to give you 1 minute to take a look at the test case. Pay more attention to where the fail assertion is put right now. Okay? Used to be put under the catch block. Let's see where it is put. Right here. Right? Take a look at this fragment of test where we got the opposite expectation. 1 minute. Especially see where the fail assertion is put. Okay? Another mental exercise you can do is to think about if I'm trying to call this decrement here, right here, and also right here. Okay, just focus on one. What if the value too small exception occur versus what if the value too small exception did not occur? How are these two possibilities are going to drive the pass or fail of the test case? That's the question you're going to ask yourself when you review later. Okay. All right, one more moment, and then we'll go over quickly. Not quickly, I'll go over again. Okay. All right, let's now talk about it. Let's say over here, what our expectation is the exception should occur because we are trying to decrement when the value is 0, right? If you look at that here, after this counter is initialized, we know that C.V will be just 0. All right? So let's say here, if the exception occur, that means we're actually going to go for this branch over here. Right here. Okay, right here. And we're going to bypass this part over here. So that one tells you that the value to small exception occur expected. as we expect. The value to small exception occurred as expected. And because that's exactly what we expect, so it's going to pass. You can see that the catch block here is simply just empty. That means nothing bad happened. If nothing bad happened for the test, it will just pass. Right? What about second scenario? Let's say we execute this, but somehow the value to small exception did not occur as expected, which means it's going to flow rather than to here. It's going to flow to the next line. And we know that, if you reach this line, you shouldn't have, because the expected exception did not occur. All right, so this part here tells you that if you go from here to here, okay, the expected value to small exception did not occur. If you kind of compare these two test cases that we spoke about, right? One where the exception was expected, the other one is the exception was not expected. That how we put the fail assertion is very critical, right? So that's something you want to think it through, over the weekend. You really want to think it through as early as you can. Okay? All right, so that's about the test design. Let's now trace them. Again, I'm going to talk about one correct implementation and one incorrect implementation. Correct implementation should be, since now we talk about the decrement method right here, right? So the decrement method specifies it may throw value to small exception. And we're going to throw that exception exactly when value is equal to its minimum. So if that's equal to minimum, we shouldn't decrement, right? That's the correct behavior. If it's not currently its minimum, we just decrement the value accordingly, right? That's correct implementation. Okay. All right, so now let's take a look at this. We're calling C dot increment here. And currently, it is correct implementation. All right, let's see the execution flow. Okay, very similar to before, but let's be precise about it. One here, and then we're going to have the value for the counter C dot V will just be 0. And then we know C dot V will be 0, and also the minimum value will just be 0, match. So this assertion here, pass. Number 2, and then number 3, right? And number 4. And we're calling this method here. So let's step into it. When we step into it, this will be number 5. And then the value for the counter will just be 0. All right? And 0 equals 0 over here should be true. Meaning that we're going to execute the body of the if branch, whereas we're going to bypass the else branch over here. So we're going to throw the exception. Now, again, back to here, which line should be 7? 9? Yeah, because value to small exception, right? Good. That means we bypass fail. We wouldn't fail the test, but instead we're going to 7 right here. That tells us the value to small exception occurred, yes, but it was expected. Value to small exception occurs as expected. And notice that here, the body of the catch block here is just empty. That means nothing bad happened, right? No assertion failure, no unexpected exception, just empty. So the test will simply execute all the way until the end and pass, and just pass. All right, any question about this one here? Let's now modify the implementation to be incorrect. All right? So what I will do is I'll take the same decrement here, that's correct, but I'm just going to modify here. I'm going to say less than. That means I'm only going to throw the value to small exception when it is strictly smaller than 0. All right? So when it is 0, I don't care. I don't throw it. All right? So apparently that's incorrect. And let's see how the incorrect implementation is going to fail the test by going through a different execution path. That's really our goal to see. All right? Just notice that it's incorrect right here. All right, let's now trace the code again. number 1, and remind ourselves, C the value will be 0. Okay? And then assert equal will just pass, right? You know exactly why you will pass, right? That one I'll leave to you, all the same. And then try here, number 3 and number 4. This will be the actual method call, but this time the version of the decrement we are calling is incorrect. So we should really expect something different happen. Maybe. We'll see. So number 4 is here. Step into the method. Number 5, right here. And we know the value for the counter currently is 0, and the minimum value actually is also 0. 0 less than 0, false. So we don't throw that exception. Bypass the body of the if branch, and we go to the else branch. Number 6, which is going to decrement the value from 0 to -1. See that? All right. Now, what's going to happen? Apparently, this is wrong. How can you actually get a value below its minimum, right? That's our requirements. The counter should always be between minimum and the maximum inclusively. Let's now go back to here. Now, where should 7 be? 7, or happen to be 7, right? Good. Right here, 7 here, all right? So here, basically, the value to small exception is expected, but it did not occur. Okay? The value to small exception unexpectedly did not occur. And once we fell here, we're going to bypass the catch block. And you can think about if you got any further lines outside the try and catch block, they will be bypassed as well. Okay? Because fail means fail right away. Okay? You don't really continue with the execution. All right. So far we have seen 4 examples already, right? About whether about exception being expected and also being unexpected. And let's now do something slightly more complicated. What about in a single test, in a certain stage, I don't expect the exception to occur. But at the other stage, I do expect some exception to occur. For example, let's say the test goes like this. I start with the counter being 0. I want to increment from 0 to 1, 1 to 2, 2 to 3. So far, it's stage number 1. I do not expect the value to large exception to occur. And then I do a 4th increment. That will be the phase number 2. That one there, we will expect the exception to occur. Right? You can see the 2 phases. In phase number 1, you do not expect anything to occur, any exception to occur, but in phase number 2, you do expect. How can we mix these 2 expectations in a single test? That's the question, right? So that'll be the 3rd example I want to talk about, all right? Let's now take a look at this. Okay, just before that, let's now just take a look at the expected behavior, first of all. Okay? So what we're going to do is phase number 1 and phase number 2, as I kind of described verbally. Let's take a look again. I'm going to call increment 3 times. So I will just let the counter reach its maximum. So far, there should not be any value to large exception occur, so far. And in the same test, I'm going to move on to phase number 2. I want to call C that increment the 4th time. But this time, the increment should really trigger some value to large exception. Right? I want to set this up. And apparently, where you put a fail assertion is going to be very critical. If you put it in the wrong way, in the wrong phase, you're going to be in trouble. Right? So that's why we want to go over this one as well. Okay, let's take a look. And I'll let you guys to really take a quick look. The highlights there also give you some hints about how you should understand this. Apparently, we got 2 unnested try and catch blocks. The first one is supposed to handle phase number 1. The second one is supposed to handle phase number 2. Right? Take a look. And then we'll talk about it. 1 minute. Okay, that one is phase number 1. And that one is phase number 2. Okay, phase number 1, let's be clear in our mind. Phase number 1, the value too large. For phase number 1, the value too large exception is not expected. And this one here is phase number 2, where the value too large exception is expected. This is why you will see that the fell assertion is going to be a little bit different. Here, fell goes here. But here, the fell goes here. Right? Okay. And we're going to trace the code in just one moment. But before that, I want to draw some arrows for you guys to think about. Right? You want to think about if I manage, somehow if I go to the catch block, if I happen to go to the catch block, that would mean some value too large exception occur unexpectedly. Here's a question. If the value too large exception really occur right here unexpectedly, of course I should fail. That's how we learn. Would I know which increment actually throw the exception? You can see I'm calling increment here, I'm calling increment here, I'm calling increment here. Do I actually know which one actually throws this value too large exception unexpectedly? I don't really know. Okay? That's actually a fact I'm trying to tell you, right? As long as either one of them will throw the value too large exception unexpectedly, I'm just going to fail the test. I don't care which one it is. Okay? So here it's also very important for you to know that, okay, either increments throwing the value too large exception is unexpected. I don't care which one it is. As long as one of them will throw the exception unexpectedly, I should fail the test. Okay? And then you can see that once we go to phase number 2, right here. So for phase number 2, here I do expect, right, the exception to occur. And now if you see that, see the increments. If this one here does throw the exception, in that way, I'm actually going to catch it. So now this value too large exception occurs as expected. Okay? And I simply do nothing here, so it will just pass. Okay? And of course, if I somehow can go from here to the next line, that means the exception did not occur as expected. In that way, I should fail. Right? That's also something we spoke about. Let's go over some example quickly. Okay? The first one. Let's say that's something that's correct. Let's say I got my increment here, right? I say I will only throw the exception when it reaches the maximum value. Right? Let's see. All right, that's our test. Number 1 will be here. So we simply initialize the counter, so C dot value will just be 0. And we'll go to the first try block. And then we try to go for different increments, right? It's going to be 3 here. Okay, so 3, and we step into number 4. When we get number 4 here, the value is actually going to be 0. 0 equals to 3. False. So we are just going to go to the else part. And then we're actually going to increment the value from 0 to 1. Right? And then when we go back, we're actually going to number 6 right here. And to increment this further. Right? It will go like this. I will let you do the rest. But you can think about number 6. So from this one here is going to increment from 0 to 1. And for this one here, it's going to go from 1 to 2. And for this one here, it's going to go from 2 to 3, right? The detailed label I can leave to you, but for now, for simplicity, I'll just say this is 6 and this is 7. You can step into and add more numbers. That's okay. Okay. Number 7. So at the end, I'm going to get C the value will just be exactly equal to 3. All right. No exception has been thrown so far unexpectedly. So that means I'm going to completely bypass the catch block because I reached the end of the try block. And then I'm just going to, just bear with me, 2 minutes, please. Okay. And then we're going to go to number 8 right here. And then we're going to check to see counter value, maximum value is 3. And counter value right now is also 3, right, as we said. Right? So that one is going to pass the assertion. Now, let's go for number 9. For number 9 here, there's a second phase. We flipped the expectation already, right? Number 9 and then number 10. We're calling the increment the fourth time. So number 10, we're going to increment. At this point, so number 10 and number 11, the value is actually going to be 3. And 3 equals maximum value is going to be true. So we're going to throw that exception as expected. Right? Throw that exception, and now when we go back, we should really go to 12 right here. Right? And bypass the fail. Because now we do expect the exception to occur. So now at this point here, we do expect. So value to large exception expected. Because it's expected, so we do nothing right here. And then the test will just pass. Right? So you can think about maybe if there's any rest of the code, you can simply put 13 over here and continue from there. Right? So the test is actually going to pass. This is the case where we got some correct implementation, and then I'll do very quickly about some other incorrect implementation on Tuesday. But before the next Tuesday, try to look at everything we have said so far. It will take me about 10 or 15 minutes to finish this lecture. And then we'll move on to equals method. All right, thank you. I'll see you next week.